this section you have quite a few graphs in front of you, and I don't want you to blow them off. These are all graphs that you should be very familiar with. First off, I know you're all very familiar with the diagonal line. You're all very comfortable with the horizontal line, so I'm not going to emphasize those as much. Let's move down here to the parabola. Obviously, it goes through the origin and -1, 1. These are 5 points that you basically want to have memorized so that when you start transforming the graphs, you're able to just take this basic graph and move it left, right, up, or down. This next graph to the right, the cubic graph, might not be one you're as comfortable with. 0 cubes to 0, 1 cubes to 1, 2 cubes to 8. And so you have these key points on the graph that you see here in the XY chart, and you pretty much need to have that memorized. The square root graph, this point at the beginning where it starts, is actually called the node at 0, 0. And notice how 1 square roots to 1, 4 square roots to 2, 9 square roots to 3, etc. going down that chart. That's what helps you to get this graph here. When you have a cube root graph, the domain is not just the positive numbers, you have negative numbers also. And notice 0 cube roots to 0, you've got -1 cube rooting to -1 and +1 cube rooting to +1. So these are all key points on this graph. The absolute value graph you should know is a V-shaped graph having its vertex at the origin. And the reciprocal graph 1 over x. Notice how when x is 1, the reciprocal of 1 is 1. The reciprocal of 2 is 1/2. The reciprocal of a half is 2. That's what gives you these curves, and the graph never touches the y-axis and it never touches the x-axis there. The reason you need to know these graphs so well is because they are basically the units that we're going to be shifting left, right, up, and down to create other graphs. Now we've got a code list that pretty much needs to be memorized, and all the values of k here we are going to assume are positive values. Assume that k is greater than 0. When you have a function f of x plus k, that says to move the function k units upward. When it's f of x minus the k, the graph is going to get moved k units downward. Now notice we have h inside the parentheses. Now with the x-axis usually moves left and right, and these h values are going to move the function left and right. But that plus h does not mean to the right. That actually means h units to the left. Remember when we were finding the vertex of a parabola or the center of a circle, you had x minus h, and we changed some signs when we went from the parentheses form to the center, the vertex, whatever we were dealing with? The same thing is going on here. When we have x minus h, that's going to refer to h units to the right. When you have a negative in front of the function, basically that is going to flip it across the x-axis or reflect across the x-axis. When the negative is inside the parentheses, that is going to reflect it across the y-axis. And when you have a number out in front, basically it's going to be talking about a vertical stretch or a shrink. If you have a positive value and a is greater than 1, then you will have a, I don't want to write the word then you will have a vertical stretch, so to speak. When a is positive but between 0 and 1, when it's a proper fraction, then you're going to have a vertical shrink. It won't be as tall as the original graph. And if a is negative, then it's going to be upside down as we have up there with that negative f of x.